So here is a hi-fi photo of the microorganisms caddy. You can see it has sample canisters on both sides. On the two sample side, this is our control side. So one of those canisters we are never touching, never opening, and that will remain the control. There is the second sample on the two side that we will open and wave and free space as a secondary control and free space. And then once complete, our samples that we're taking on locations at the airlock and on the lab are going to be on the sixth sample side. Now I have some hi-fi hardware to show you. So the canisters look like this, and they are sealed inside so that they are safe from anything in the environment until they are opened. Here we have the handle. These are modified old shuttle tools that have been used for this purpose. So on the handle, you stick it into the caddy end effector, and then you can just press the locking lever and rotate, and then pull the sample out like this. And this will show you on the end of it, it's a standard COTS example of a swab that we will be using for each of the sample locations. And then so we have to be very careful that this swab doesn't touch any inadvertent areas because that could invalidate the science. And then once complete, you very carefully put this back in here and then rotate it to the locked position. And then to remove the handle, you slide this down to reveal two levers, press them, and you can pull the handle off. So the other piece of hardware that I have here is for the alpha magnetic spectrometer evaluation that we're doing. So on the future EVA, one of the assessments that the team is very interested in is they want to use some of these cable locations for various future needs. But they need to know what kind of access they have to these various cables on this particular patch panel. So they created this demate tool that they plan to use in the future, and this is just a simulator tool. So they want to see if they can need any modifications to the tool in order to access any of the samples. So how you use the simulator tool is they're going to stick it over the cable, careful not to inadvertently demate, because we don't want to demate any of these cables on our EVA, to see if they have access. And they will do this same operation with 12 different connectors to see what their access looks like. In the future EVA, they will choose the 3 best cable locations to see how they can reintegrate signals and information. And that is all I have for the microorganisms EVA, and I will hand it over to Sandy.
Thank you, Frank. Good afternoon. So I'll talk to the radio frequency group, or RFG EVA, retrieve number 2. What we're doing is really 2 EVAs. Farouk has 3 in 1. I have 2 in 1. First half of the EVA, we're going out to the port side of the International Space Station. The primary task out there is to do the remove and replace of the trundle bearing assembly. Laurel will be doing that task. Meanwhile, Jasmine will be doing a number of other tasks. One primary task is removal of an H fixture. This is an attachment to the beta gimbal assembly. We need that H fixture removed so we can install an ISS rollout solar array later in a future EVA. She's going to also do a cable adjustment so that we have free movement on one of the camera ports outboard on the station. Then once we're done with the port side task, we'll actually come close to the airlock. We'll be on an external stowage platform, and we'll be doing a second attempt at removing the RFG from its stanchion. So we've done quite a bit of work. We understand what the primary cause of the RFG not being removed. There are 5 aft wedge clamps. They're holding the box onto the stanchion, and we will show you a video and describe the EVA, and then I'll come back and show you the tool that's been designed. This is the second radio frequency group retrieval EVA. EV1 and EV2 egress the airlock and proceed to the forward face of the truss. Heading port, the crew put down safety tether green hooks and continue outboard of the solar array rotating joint. EV1 goes to the 2 alpha beta gimbal assembly and secures a crew lock bag of tools. Using the pistol grip tool, EV1 releases 4 bolts on the H fixture and then removes it. EV1 then surveys the worksite. Meanwhile, EV2 goes to the solar array rotating joint and removes a cover, exposing a trundle bearing assembly. After disconnecting an electrical cable, EV2 uses the pistol grip tool to release 3 bolts and remove the trundle bearing assembly. EV2 photographs the surface, then applies lubricant to the rotating ring using a grease gun. Back at the beta gimbal assembly, EV1 continues a photo and video survey of the sites where an ISS rollout solar array modification kit will be installed on a future EVA. EV1 returns inboard to the camera port 8 worksite to adjust a cable interfering with movement of the camera light assembly. After lubricating the surface, EV2 installs a new trundle bearing assembly. EV2 then certifies the worksite. EV2 surveys the worksite before replacing the cover. From camera port 8, EV1 translates inboard, down a strut, and temp stows the crew lock bag on the U.S. laboratory. EV1 goes to the airlock, retrieves a different crew lock bag, and takes it to the external stowage platform number 2. EV1 retrieves a portable foot restraint and installs it on the robotic arm. Then EV1 ingresses the foot restraint and the robotic arm flies to the radio frequency group aft position. EV2 returns along the truss back to the airlock, stowing the large bag outside the airlock, and joins EV1 on the stowage platform. The crew work together to fold back the multi-layer insulation surrounding the radio frequency group. At the aft wedge clamps, the crew remove any rubber covering the clamp nuts
using needle nose pliers. Then, using a ratchet wrench and a specially designed tool, they loosen the 5 aft wedge clamps. EV1 is then flown to the forward face of the radio frequency group, releases 4 structural bolts, then removes it from the stanchion. EV1 then flies it to the airlock, where both crew secure it inside. Back at the stowage platform, EV1 egresses the arm, removes the foot restraint, and retrieves the earlier temporarily stowed tool bag. EV2 secures the covering over the stanchion. Then both crew return to the airlock and ingress.
So this is our specially designed RFG wrench. You'll see it's got a fairly large handle. This is to enable a pressurized EMU glove to go over. We've always got a tether point so we don't lose tools during an EVA. What's unique about this is that the wrench part of it is actually very thin, and that's because our access point to the bolt is not compatible with our usual EVA tools. So we'll have one crew member holding this onto the bolt head while the other crew member releases from the nut side using a standard EVA ratchet wrench or the pistol grip tool. So with that, that concludes my part of the presentation.